So 5.4, the derivative of y equals sine x and y equals cos x. So derivatives of sinusoidal functions. D by dx of sine x, so this just means taking the derivative of sine x gives us cos x, and the derivative of cos x gives us negative sine x. So something that I used to do in university is I used to go to the side of my paper and I would write sine, like S, well, I just wrote S. So sine to cos is normal. So if I had positive sine, I'm going to get positive cos. But then if I had cos, right, so positive sine to positive cos. Now if I have cos, I'm going to have negative sine. Then if you think about it, if you had negative sine here, you would actually have negative cos because this negative would stay as like that constant. So negative cos. Then here, if I had d by dx of negative cos, I should put d by dx. So it's proper math. Okay, if I had negative cos, and this cos itself is going to turn into like negative of negative sine, which gives us positive sine x. So what I did in university is, this is like a loop. Sine goes to cos, cos goes to negative sine, negative cos, and negative cos goes to positive sine, and it loops. Okay, so I like this at the side of my paper because sometimes going with the positives and negatives, it's a little bit confusing. So here we go, let's try this. Example 1, determine dy by dx for each function. So y equals cos 3x. Okay, so dy by dx equals, okay, so the derivative of cos is just negative sine. So we're going to write negative sine, and this right here is our normal 3x, just like how we see it. But because this is not the function x and it's actually a different function, we have to use chain rule, so times 3. And this can just be simplified to negative 3 sine 3x. Okay, b, dy by dx. Now, if we have x times sine x, this is multiplication. So this is going to be product rule. So I'm going to call the x my u and my sine x my v. So product rule is going to be u prime v plus uv prime. So derivative of x is just 1 times sine x, like v as itself, so sine x, plus u, which is x as it is, times the derivative of v. So derivative of sine x is just cos x. So written a little neater, this is just sine x plus x cos x. Now example 2, determine dy by dx for each function. So a is y equals sine x squared. So we can treat this as like our normal one would be sine x. Well, this function is actually x squared. So we're going to go dy by dx equals, okay, so what's the derivative of sine? Derivative of sine is just cos. So cos, we write it as it is, x squared, but then we have to take the derivative for chain rule of the x squared, which is 2x. So this is 2x cos x squared. And I personally like to put this x squared into brackets because then we don't get it confused with the product law. Remember, sine, cos, and tan don't mean anything without this function of x beside it. Okay, so b is a little bit different. Okay, so we're going to go dy by dx. So we're finding the derivative of sine squared x. What does sine squared x actually mean? So sine squared x came from sine x being multiplied by sine x. Another way to write this is sine x all squared. Now, when we take the derivative, this form makes a little bit more sense because we can better identify that we have to bring the 2 to the front and then subtract 1. But you won't see it like this. You'll always see it as sine squared x. So let's bring this 2 to the front. So 2 sine, and then that will subtract 1, so we just leave it, x. Okay, we don't have to put that 1 there. We can. And then chain rule, what's the derivative of x? Well, that's just 1. So we didn't really have to do that because this function here is just an x. So yes, this is 2 sine x. Okay, so derivatives of composite sinusoidal functions. So if y equals sine f at x, which is what we just saw, then, so from up here, I just did a hands-on. Here's the theory behind it. dy by dx, so the derivative equals cos, so derivative of sine is cos of that function times, and this is our chain rule, the derivative of that function. So this is chain rule. That's what we just saw. Okay? And if cos f at x, y equals cos f at x, then the derivative is negative sine, leave the f at x as it is, and then chain rule it. So example 3, determine dy by dx for this function here. So y equals cos 1 plus x cubed. So we're going to go dy by dx equals derivative of cos is negative sine. This is our function. So we're going to leave our function as it is, 1 plus x to the 3. And then we're going to multiply by f prime at g, or sorry, f prime at x, which is derivative of 1 is just 0. And the derivative of x cubed is 3x squared. So I would just write this 3x squared in front. Negative 3x squared sine 1 plus x cubed. Example 4, determine y prime for y equals e to the exponent sine x plus cos x. It's supposed to be cos x. So we're going to have y prime equals. So the derivative of e is just itself. So we're going to go e sine x plus cos x. Then what we're going to do is we're going to multiply by the derivative of this f at x up here. So the chain rule. So derivative of sine x is just cos x plus the derivative of cos x is negative sine x. So I get y prime equals e sine x plus cos x times, let's go cos x minus sine x. So all I did there was collect these two signs. Example 5, determine the equation of the tangent to this graph, y equals x times cos 2x at this point here. Okay, so first we know that we're going to need a full coordinate. We don't just need the x, we need an x comma y. So let's just substitute pi by 2 directly in here. So y equals x is going to be pi by 2. Cos of 2 times pi by 2. Okay, so we have pi by 2, cos, and then these two 2's cancel out, and we have cos of pi. Now, if we're thinking about cos of pi, I go to the side of my paper I draw me my cos curve. I say, okay, what's cos of pi? Well, pi's right here. That means we're going to have a value of -1. So I get y equals pi by 2, bracket -1. So y equals -pi by 2. So our full coordinate here, I'm going to put this up here, pi by 2, comma, -pi by 2. So now let's do step 1, find the slope. So we're going to find the derivative of this. We're going to use product rule. So our x's are u, and our cos 2x's are v, and our product rule is u prime v plus uv prime. So y prime is derivative of u, so derivative of x is just 1, okay, and then v as it is, cos 2x plus u as it is, which is x, and then v prime. So the derivative of cos is negative sine. We're going to write the 2x as it is, and then we're going to chain rule it. What is the derivative of 2x? Well, it's just 2. So simplified, the derivative of our function is cos of 2x minus 2x, right? So we took the minus sign, the 2 and the x, and then sine 2x. That's our derivative. Okay, we want to find the actual slope though at this point, at pi by 2. So y prime at pi by 2 is going to equal, and we just sub in, cos of 2 times pi by 2 minus 2 pi by 2 sine 2 pi by 2. Okay, these 2's cancel out, these 2's cancel out, and these 2's cancel out. We're left with cos of pi minus pi sine of pi. So we already drew the cos curve, and we already labeled pi, so cos of pi is -1. So this cancels to a -1. Okay, so minus pi. Then we want to know, and I'll do this in blue again, we want to know sine of pi. So the sine curve looks like this, and pi again is right in the middle. Okay, so the sine of pi is 0. So that just cancels out. We're left with -1. So our slope is -1. Okay, so step 1 is find the slope. Step 2 is find the y-intercept. So I'm going to write y equals mx plus b on my screen. And we know that the m is -1, right? That's our slope. And our xy is, from up above here, pi by 2, -pi by 2. So let's sub in pi by 2 to the x and -pi by 2 to the y. Okay, so we have -pi by 2 equals -1 times pi by 2 is again -pi by 2, and then plus b we just bring down. If we were to take this -pi by 2 and bring it over the equal sign, we get -pi by 2 plus pi by 2 equals b. And these two are the same but opposite signs, so we have 0 equals b. So simply our step 3 is write the equation. So the equation of our line, or sorry, our tangent line is y equals -1x. Okay, because you don't have to write here plus 0. So that's it, -1x. Example 6, determine the max and min values of this function here. F at x equals cos squared x. On the interval, x is an element of 0 to 2 pi. Okay, so that's one rotation. And that's only one rotation, like one cycle, if there is, and there isn't, a horizontal stretch or compression. Okay, so for the max and min, you want to find the first derivative. So what we're going to do is we're going to bring down this 2 in front. Okay, we're going to have 2 cos x. Then we're going to chain rule it. Now we have to multiply by the derivative of cos, which is negative sine x. Remember from yesterday, sine cos, negative sine, negative cos, and then back up. Okay, so derivative of cos is negative sine. Okay, I'm just going to simplify this a little bit more. So f prime at x equals, I'm going to go negative 2, right? So I'm going to collect the negative and the 2, and then we have cos x sine x. Okay, for max and min values, we want to find the critical numbers. So set the derivative equal to 0. This is going to tell us, for example, when we have the horizontal tangent. Okay, so when we have that turnaround point. Okay, so if we have 0 equals negative 2 cosine, or cos x sine x, we can divide both sides by negative 2. So that goes away. And now we have 0 equals cos x sine x. Okay, so there's going to be 2 situations here. There's going to be, because there's 2 factors. When does cos x equal 0? And then when does sine x equal 0? So I'm going to draw cos x. Okay, so there's no transformations on this. It's just simply the cos curve. So I'll draw it down here. Cos starts at a maximum, goes to a minimum, and back to a maximum for one rotation of cos. Okay, so this is going to be y equals cos x. Okay, remember maximums occur at positive 1, minimums occur at negative 1, and the equation of axis occurs at 0. And then there's going to be one of the 5 key points every pi by 2. So pi by 2, pi, 3 pi by 2, and then this is 2 pi. Okay? So we are looking for when cos x equals 0. So we're looking for when this curve equals 0. That occurs here and here. Okay? So there's going to be 2 solutions here. There's going to be x equals pi by 2 and x equals 3 pi by 2. Okay, so 2 solutions for this factor. Now, same thing, but now we have to do sine x equals 0. So again, no transformations on the sine x. So we're going to start at 0, 0. I always think sine starts at the start, right? S for sine, S for start. And then up, equation of axis, minimum, equation of axis. Okay, sine has maximums at 1, minimums at negative 1, and equation of axis at 0. And every pi by 2, there's going to be a key point. Okay, now we're looking for when sine x equals 0. So that occurs 3 times. It occurs at 0, at pi. Oh, I put pi, I mean 2 pi. Sorry. Okay, so we have 3 more solutions here. X equals 0, pi, and 2 pi. So back to the question, determine the max and min values, okay, on 0 to 2 pi. So what we want to do is we want to take the original, which is y equals cos squared theta, or cos squared x, and we want to plug in y at 0, y at, and I'm going to do these in order, like number line order, 0, pi by 2, y at pi, y at 3 pi by 2, and y at 2 pi. Okay, so this is essentially going to be cos of 0, and then we're going to get a value, and then we're going to square it. That's what cos squared means. Okay, then we're going to go cos of pi by 2, and we're going to get a value, and we're going to square it. Then we're going to do cos of pi, we're going to get a value, and then we're going to square it. Okay, cos of 3 pi by 2, same thing. Grab a value, square it, and then cos of 2 pi, and then square it. Okay, so we already did the legwork. Go back down to these two graphs here, and we're going to say, okay, what is cos squared? Okay, well, cos 0. So cos of 0 is 1. It occurs right here. So this is 1, and 1 squared is just 1. Now, cos of pi by 2. Cos of pi by 2 is 0. Okay, so this is 0, and 0 squared is 0. Cos of pi is negative 1. So if this is negative 1, and we square it, we're again going to get 1. Okay, cos of 3 pi by 2 is 0. 0 squared is 0. And cos of 2 pi right here is 1. So 1 squared is just 1. So we're going to have a max at the 1s. Oops. And a min at the 0s. And if we want to write a concluding statement, so max of 1, right? You put max of the value at x equals 0, pi, and 2 pi. That occurs 3 times. Okay, and we're going to have a min of, put the value 0 at x equals, okay, it occurs at pi by 2 and 3 pi by 2. Okay, and because the domain here is 0 to 2 pi, we can list these and be okay with it. If this oscillated forever, we would put more of an, we would put an expression with an n in it to show that at every pi, we're going to have a maximum. So if we continued, be like 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on, and we would express that a little bit differently. But because this is just 0 to 2 pi, we can just write this statement and we're done.